In this lesson, we're going to be talking about permutations. And permutations are the number of outcomes that are possible when the order that you're selecting things in matters. So permutations are the arrangement of any number of items in a specific order. A specific order. For example, first, second, and third place. Or if I'm selecting one person to be president and one person to be vice president. If the different places they go matters, then this is called a permutation. The symbol that we use for permutations when we have n items that are being arranged are at a time. For example, we have 5 people. We're going to choose 2, 1 to be president and 1 to be vice president. Then n would be 5 and r would be 2. So how many total items, and then how many are we actually going to use? And sometimes we use all of them, and that's fine too. That would mean that both numbers for n and r were the same. This looks like NPR with a small n and a small r is equal to n factorial divided by n minus r factorial. And we'll get into factorials in just a minute. One of the things you need to remember is that all of the items you're arranging must come from the same group. So what is a factorial? This is when we start using this exclamation mark in math. And factorial means that you multiply the number that you have times each integer that is less than it until you get to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. 3 factorial would start with 3. We would just say 3 times 2 times 1, which would be 6. By definition, 0 factorial is 1. And there's a lot of discussion about why that isn't 0, and there's a very good explanation for it, but it's a little bit long. So for now, we're just going to remember that 0 factorial is 1. So when we see that in a computation, we realize it doesn't actually equal 0. So the first thing we're going to do is we're going to practice simplifying this. So if we have 8p5, that means n is equal to 8 and r is equal to 5. We have 8 items and we're going to arrange 5 of them. So using the formula from above, we're going to put n factorial over n minus r factorial. So that would be 8 factorial over or divided by 8 minus 5 factorial, which is 8 factorial divided by 3 factorial. Doesn't look like a 3. Let's fix that. And then to work this out, I go ahead and write it in expanded form. 8 times 7 times 6 times 5, 4, 3, 2, 1. Divided by 3 times 2 times 1. Now, rather than multiply all of those numbers out and get the large number I would get, I want you to remember that since the top is multiplication and the bottom is multiplication, we can cancel out any common factors. So we could do a variety of things. I could cancel the 3 with the 3 and the 2 with the 2, or I could say 3 times 2 is 6, and I could cancel that way. It's up to you, but 2 divided by 2 is 1, and 3 divided by 3 is 1. And so we end up with just 8 times 7 times 6 times 5 times 4, and that's going to be what 8p5 means. When you multiply those numbers together, you get 6,720. The next example is simplifying 10p3. So n is equal to 10 and r is equal to 3. We're going to do 10 factorial divided by 10 minus 3 factorial, which is 10 factorial divided by 7 factorial. Now you can see that it would get tedious to write out 10 times 9 times 8 times 7 times 6 times 5 times 4 and so on. So what I do with this, when I have a 7 on the bottom and a 10 on the top, I'm going to start with 10 and I'm going to count down 10 times 9 times 8 times 7 until I get to the number that's identical to the number on the bottom. And I'm just going to stop and say 7 factorial, because I know 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, so it takes care of all of that. And when I also have a 7 factorial on the bottom, since those two factorials are identical, they cancel each other out. You can only cancel if the factorials like that are identical. You couldn't do it with, say, an 8 factorial and a 4 factorial. You'd have to do some different things. And we'll just practice and we'll see what happens with those. But we end up here with just 10 times 9 times 8, which is 720. So now let's get into how this works in a real life situation. We said at the beginning that this is only when order matters. So what does that mean? Well, anytime I'm arranging something, so you might see the words arranging in a row, or you might be organizing books on a shelf, or they might say in a line. We want to put kids in a line, maybe for a picture or a batting order or things like that. Those are things that tell you that the order matters. If you're going to be able to look at it and see a change, is the kid first in line? Is the kid second in line? We've all been 5 years old before. We know there's a difference in being first and being second. So keep that in mind when you're thinking about permutations. That's what you're thinking about. In example 3, it says, how many ways can I organize 4 books on a shelf? So I'm organizing them. I have that key phrase on a shelf. So I'm thinking like in a librarian, how many different ways can I organize these 4 books? Well, n is going to be the number of items that I actually have. So n is 4. And then r is the number that I'm choosing to arrange. Well, it looks for this problem like I'm going to arrange all of them. So r is also 4. So this is going to say 4p4. Well, that's n factorial, so that's 4 factorial over 4 minus 4 factorial. So that's 4 factorial divided by 0 factorial. So now you see why it's important that we talked about 0 factorial and how that's just going to be 1. So 4 factorial is 4 times 3 times 2 times 1, and 0 factorial is just 1. So we see there are 24 ways that we can organize 4 books on a shelf. Example 4 says, I'm going to choose 3 of the 8 girls on the basketball team to take a picture. How many ways can I have them stand in line for the picture? So I know the order matters because I have that they're standing in a line for a picture. N is how many girls we have. Well, we have a total of 8. How many are we going to choose to put in the picture? 3. So this is 8p3. We'll do n factorial. That'll be 8 factorial over 8 minus 3 factorial. Now this is another one. 8 factorial is kind of long, so I'm going to start with 8. But I'm only going to count down to 5 factorial. Since I have a 5 factorial on the bottom, I know that those two will cancel each other out and leave me with just 8 times 7 times 6, which is 336. That's how many different ways there are. I can choose 3 of the 8 girls and line them up for a picture. Now, if we were just going to choose those 3 girls and the order didn't matter, it would be an entirely different problem, and we'll get into those in the next lesson. So this is only when the order does matter. Now we're going to talk about rearranging the letters of a word. So in this example, we're ordering the letters of the word happy. So there's 5 letters, and we're going to organize all 5 letters. And hopefully you noticed on the last one, let's see, when we organize 4 books on a shelf, anytime you're talking about organizing all of the items, your result is going to be that number factorial, because you'll end up with a 0 factorial on the denominator. So for a problem like this, it would be like 5p5, which would end up being 5 factorial. However, you may notice in the word happy that there are 2 p's. Well, we will not notice if we switch the p's. So in order to take that into account, we need to divide by how many times a letter is repeated. And so the p is repeated twice. So we're going to do 5 factorial divided by 2 factorial. When you look at the word banana, you have 1, 2, 3, 4, 5, 6 letters in the word banana. So you would start out with 6 factorial. And then you would divide by, well, you have 1, 2, 3 A's and 2 N's. So I need to work with both of those. So I would divide by 3 factorial times 2 factorial. So you notice these get a little more complicated when 2 of the items are exactly the same. But we can go ahead and work these out. 5 times 4 times 3, which is 2 times 1, divided by 2 times 1. We always simplify before we multiply. We don't want to multiply and get giant numbers. 5 times 4 times 3. There are 60 different ways to organize the letters of the word happy. For banana, we've got 6 factorial divided by 3 factorial times 2 factorial. And then we're going to start canceling. We can cancel this 3 and 2 with this 3 and 2. Then we still have a 2 down here, so I'm going to cancel that 2 with the 6. 2 goes into 6 3 times, and we're left with 3 times 5 times 4, which is 60 again. We have 60 ways to order the letters of the word banana, and 60 ways to order the letters of the word happy. How many ways could you organize the letters of the word mom? It would be 3 factorial because there's 3 letters, and there are 2 M's, so it would be 3 factorial divided by 2 factorial, which would just be 3. We also use this when we're talking about some different situations. Here we have someone who has 5 children, and they have 3 girls and they have 2 boys. And how many ways can you order them? And that means like they could have had the 3 oldest could be boys and the 2 youngest could be girls. It could have been boy, girl, boy, girl, boy. How many different ways could that family look? And the way I like to do these is by writing out what one possible outcome would be. Well, they could have had the first 3 boys, and then they could have had 2 girls. And once we have this, we can use the same idea with the problems above, arranging the letters. Well, how many letters do we have here? We have 5 letters, so 5 factorial. How many of those letters are B's? 3. And then we have 2 G's. So 5 factorial divided by 3 factorial times 2 factorial. And then we'll simplify. We see that there are 10 ways for the boys and girls in that family to be ordered.